Hi guys, in this specific discussion we are going to look at one of the characteristics of triangles, and of course I'm going to use triangles particularly in this specific discussion as one of the illustrations which are going to assist us understand this specific concept. So therefore, from our previous discussion we have looked at different characteristics of especially perpendicular bisectors, angles and segments, and in this particular case we have talked about the aspect of a segment of a triangle. So in this case, we said that a triangle has got three segments. So I can just give a clear illustration. We say that a triangle basically has got three segments, and in this case, I'm going to use A, B, and C. And therefore, I say that I'm going to have AB as one of the segments of this specific triangle, and then I'm going to have BC as another segment, and CA as the last of the three segments of this specific triangle. Now suppose I have a line that is going to be running from a particular vertex. Let's say vertex, this is C, and it's going to be dropping perpendicularly to this specific vertex that is going to be of course AB. I'm going to refer to this specific line as an altitude. Now, from our normal description of perhaps some of the physical sciences like geography, we're going to see that, the physical description of some aspect of geography, we're going to see that the concept of altitude basically refers to how high something is, and that we're going to transfer this specific concept to geometry, whereby we're going to describe altitude as the distance that is perpendicular to the bottom side of an angle. So in this particular case, I've considered angle AC. B. So this specific angle ACB is opposite to segment AB. So therefore, a line that is going to drop and make a perpendicular to segment AB from this angle C is going to be referred to as our altitude. So therefore, we're going to see that we can have three different opposite sides or angles for this specific triangle, and we can be able to describe them in various aspects. So therefore, it's not necessarily obvious that the altitude of these specific triangles are going to be elaborate, but we can just use a specific case in order to illustrate this specific concept of a triangle. Now, I mentioned that we can be able to have that one we're going to look at it in some of an exclusive topic on different types of a triangle for equilateral, isosceles, and perhaps other aspects like the right triangle. Now, these different types of triangles are going to have various geometrical aspects of altitude, and the example that I'm going to give is going, of course, to shed light for us on this specific characteristic that I'm talking about. So suppose we have a triangle that is going to be given as A, B, C. We have said that we can be able to drop a perpendicular from the point C, which is going to be a perpendicular bisector, of course dividing the segment AB, or dividing the segment AB given as such. And of course, we're going to see that, or just a drop from this specific point, we're going to see that so the angle C is going to be having a perpendicular bisector on segment AB, and therefore B is going to have a perpendicular bisector on segment AC, and A is going to have a perpendicular bisector on segment BC respectively. So suppose I have a triangle which I can be able to just give an illustration as such, and this is a triangle, and this is going to be ABC. So therefore I'm going to have A having a perpendicular bisector at this specific point, so it's going to be perpendicular bisector that is going to draw from this specific point of A to CB given as such. So therefore we're going to have that one, and then we're going to have angle B having a perpendicular bisector that is dropped to AC. So therefore for us to achieve that, we're going to use a different strategy. So we can be able to extend this specific aspect of AC using an extrapolation given as such. So therefore, as we said, B is going to have a perpendicular bisector from with AC. So that point is going to be a point dropped from that specific point, and then it's going to form a perpendicular bisector with this extension of AC given as such. And then we're going to have C having a perpendicular bisector with AB. So therefore, we're going to have an extension or extrapolation over this specific point for AC or segment AC given as such. And that perpendicular bisector is going to be dropped from this specific point. Now, as we can see, we are going to form a particular, let's regard this one as point O, which is going to be a point of intersection between these three specific perpendicular bisectors of this specific triangle ABC given as such. So this specific point whereby this particular intersection is going to be occurring, it's going to be referred to as an orthocenter. And orthocenter, basically, the orthocenter is the intersection of this is going to be the intersection of these three altitudes, which are altitudes of the points C, B, and A given as such. So from maybe perhaps illustration, or basically trying to analyze some of the characteristics of these angles and the angle measurements from the numerical evaluations, then therefore it's going to be clearer for us. But what we have talked about in this specific case is that we are going to have a distance that is perpendicular to the bottom of the respective sides of these triangles, which we are going to refer to as altitude. And the altitude of a triangle are going to be the line segments, of course, which are going to go from the respective vertices down to the perpendicular, down perpendicularly to the opposite sides as I've mentioned. So basically, for a triangle is going to have three specific altitudes. And of course, as we have said, these altitudes are not going to be obviously shown as such, so it's going to need some kind of extrapolation as I've done in this specific triangle for the sake of illustration. And we're going to have this specific point of intersection over the three altitudes that is going to be referred to as an orthocenter. And this is going to be the point of intersection of the various altitudes that we're going to come across. Now, we have given an example of maybe a calculation, but it's going to take us long, and I'm going to do it in a specific video for us to understand this specific concept in terms of evaluation. But I hope that we have understood the concept of altitudes and how we can be able to describe various altitudes of triangles if we come across them, especially in geometrical figures like triangles. So that is it for now, guys. Bye, God bless you. Catch us in our next video.